Hello, class. We're about to start section 3.7, and I know the problems are 1 through 4 all. However, I'm only going to do problems 2 and 4. So problem number 2 is on page 328, and it states 2a. It says, consider the following data set for the variables x and y. Plot these points on the following grid. Okay, now, instead of me drawing a grid, I am going to put this in Desmos so you can see what it should look like. Because anything I draw here would be an estimation. I think it'll look a lot cleaner in Desmos than it would me drawing it on a sheet of paper. Let me put in these values first, as we're probably going to have to refer back here. All right, so what I'm going to do now, I'm going to put all of these values into a table on Desmos. So I would do the plus sign, go to table, and then start typing in the values. So you have 5, 8, 11, 15, then 20. Then the Y values, 70.2, 50.7, 35.1, 22.6, and 9.5. Okay, so now I'm going to zero in just to give you all an idea of what this graph looks like. Let me put this mouse here. As you see here, this is a representation of the graph because there's only 5 points. And I can move it here so it'll be a little bit more clear for you. Okay, so this is the representation of the graph. So now, so that would take care of part A. Let me expand this. I thought this would expand all the way out. Okay, that's part A. Now, we want to go to part B. Part B says, using your graphing calculator to determine both a linear regression and an exponential regression model of the data. Record the equations for these models here. All right, so we're going to get a linear and we're going to get an exponential model. Now, what I'm going to do, I'm going to write out the answer for both of these, and then I will show you on the graph the answers. And the reason being is I want you to be able to copy these answers down, and then you could take a look at what we get when we put it in the calculator. So these are the answers we would get for our linear and exponential regressions. So if you need to pause it, and then I'm going to go over here to Desmos and start the process. All right, so we will go here. Oh, this is a little, all right, let me move this over just a tad bit. Okay, so we would do Y sub 1. We'll hit the keyboard, hit ABC, hit the tilde, and we'll do MX1 plus B. Okay, now this gives us our linear. If you notice here, the slope is a negative. You notice here we rounded to 2 decimal places. It's a negative 3.95 and x, and then plus 84.20. This is where we got our linear equation from. Now we would take the same data and do y1, the tilde, it'd be AB. We'll hit the 1, 2, 3, and we'll take it to the x1 power. Now, if you look here, you notice here that we have A is 128, but we got 144. B is this value here, but we have a different value. You're supposed to click log mode after you get the exponential equation. you're supposed to click log mode, and then it would change the numbers to the proper amounts. I don't know why Desmos has it set up like that, but that's how Desmos has it. So you have to be very conscious of that. So it'll be y equals 144.21. And then in parentheses, typically we round the b of the exponential equation, usually to 3 or 4 decimal places, sometimes even 5. But we typically don't round to just 2 decimal places unless indicated. So this is how we get the 0.877 to the x. Now, that is our answer for A and B. Now we go here to C. C, it says use the graph of each equation in part B to determine which model appears to fit the data better. Okay, listen. There's a quick, easy way to see which model fits the data better instead of just looking at the graphs here. If you look at your correlation coefficient, which is your R value, whichever one of these R value is closer to either -1 or closer to +1 is the better model. If you look here, this is a -0.9793, and this is R equals -0.9943. So the exponential model is closer to -1, because to have a perfect exponential or linear model, the R either has to be +1 or -1. And if you're trying to pick which one is better, whichever one is closest to the +1 or -1 is the correct answer. So in this case, the graph of the exponential regression is better based on the correlation coefficient. Now, if you need to remember what the correlation coefficient is, you could put a parenthesis and then a lowercase r so that you would know what you're looking for. Okay, now we go to D. It says use the better model to determine y when x is 13 and y when x is 25. Okay, so we will have y is equal to 144.21 times 0.877, and they say y, well, x is 13, that'll be taken to the 13th power, and then y is equal to 144.21 times 0.877, and then you would take x to the 25th power. Now, when you put these in your calculator, you're going to get 26.18 for the first one, and then you will get 5.42 for the second. That's when you put in those equations. Now, what I can do, I'll put in the equation just to show it. 144.21 parentheses 0.877, and then we would take that to the power of x. Now, once we get this here, we could click on this wheel here, click on the table, and then we could just type in the values. It was 13 for x, and then we also had 25 for x. And then just round these to 2 decimal places, and it gives us the same answers. Okay, now we go to E. It says for the exponential model, what is the decay factor? Now the decay factor is this value inside the parentheses. So we could say decay factor is equal to 0.877. Now, you could leave it as this, or sometimes they will write it as B is equal to 0.877, because B deals with your factor, whether it's a growth factor or decay factor. All right. Now we move on to F. It says, what does it mean that the decay factor is between 0 and 1? basically as the input, and then we could put in parentheses x or t value. Usually it'll be x or a t value. The input increases. The output, which is usually y or some type of function like f of x or like f of t, or we know we could do the g's as well. The output decreases. Okay, now we come here to G. It says, what is the half-life of the exponential model? Okay, so first of all, the half-life. Okay, we look at our original starting point, which is 144.21. So if we take half of that, that'll be about 72.11 or 72.10. So what we could do, we could go here. We notice from 2 to 13 is decreasing. So we can play around with some numbers. Let's try 6. We see that 6 is 65. Then we could try 5. Now, if you notice here, remember, we're trying to get about 72.11. So that means that your answer is between 5 and 6. So if we try, let's try 5.3. That's a little bit off. So let's try 5.29, and that's 72.02. That's 5.28, and that's about 72.11 or 72.12. So we should go with 5.28. Yeah, I don't know why it keeps going like that. Okay. So here we should have 5.28. So we will have approximately 5.28. And that's basically it. All right. I don't know how to get rid of this little box here, but that's basically it for problem number 2. Did you all have any questions from problem number 2? All right. We move on now to problem number 4. Now, problem number 4 states, according to GfK, Germany's largest market research institute, the total sales value of smartphones in China from 2013 through 2017 is as given in the following table. The sales are measured in billions of dollars. Okay, so let me draw this table. So we had a year. I'll abbreviate since you all have the textbook. We have the year, and then I'll put S for the sales. So we had 2013 is 90.1. 2014 is 99.0. 2015 is 116.2. 2016 is 133.5, and then 2017 is 148.3. Okay, so now this will be 4A. So 4A, it says use your graphing calculator to determine an exponential regression model for the data in the table. Let the independent variable x represent the number of years since 2013. So the first thing we need to do is reflect this as since 2013. So this would be 0, and we know this is really our x and our y value. This would be 0, 1, 2, 3, and then 4. Okay, so now what we could do here, if we just want to utilize what we already made, we could go right up here and just change these numbers, and then the regression model will automatically update. So we could have 0, 1, 2, 3, and then 4. And we could put in our values: 90.1, 99.0, 116.2, 133.5, and 148.3. Okay, now we already put the exponential regression down here, so it automatically updated itself. So we would have, they wanted the equation, and it didn't tell us, did it tell us to round? It didn't tell us to round to a certain amount of places. So we're around the 3 places. It'll be 89 point, oh, let me scroll down here, 89.105. That'll be our A. Our B is what goes on the inside. We'll round that to 3 decimal places too. So it'll be 1.138, and we would take that to the X power. Okay, now we go here to B. It says, assuming the rate of growth continues, approximate the value of smartphone sales in China in 2025. Now watch this. They're saying the sales in 2025. But remember, our chart is since 2013. So when we subtract that, that means that our X is 12. So we have Y is equal to 89.105 times 1.138 to the 12th power. Now, when you put that into your calculator, that's going to give you approximately 420.3, and that's billion. So it's 420.3 billion in smartphone sales. In 2025. And that is basically it for problem number 4. Did anyone have any questions? Okay, well, we are done for lesson 3.7.